Hi everyone and welcome back to the Repair and Installation TV channel. A state-of-the-art forestry machine represents the pinnacle of technological advancements in the field of forestry equipment. These machines are designed to provide exceptional performance, efficiency, and versatility in various forestry operations. The heart of the state-of-the-art forestry machine is its powerful and versatile harvesting head. The machine is equipped with a high-performance head capable of efficiently felling, delimbing, and processing trees of various sizes. The harvesting head incorporates advanced sensors and control systems to optimize cutting precision and maximize productivity. The harvest head is a critical component of modern forestry machines used for felling, delimbing, and processing trees. It is an attachment that is mounted on the forestry machine's arm or boom, providing the cutting and processing capabilities required for efficient timber harvesting. Let's explore the harvest head in more detail. Design and functionality. Harvest heads are designed with a combination of saws, knives, and hydraulic mechanisms to carry out various functions during the harvesting process. The specific design may vary depending on the manufacturer and the intended application. The head is engineered to deliver precise and efficient cutting, delimbing, and bucking operations. Cutting mechanisms. The harvest head incorporates cutting mechanisms, such as chainsaws or circular saws, to efficiently fell and cut trees. These cutting elements are powered by hydraulic motors, ensuring high cutting performance and enabling operators to process trees quickly and accurately. Delimbing and debarking. After felling a tree, the harvest head is capable of delimbing, which involves removing the branches from the main stem. Delimbing knives or rollers are integrated into the head, and they work in conjunction with hydraulic power to remove branches efficiently. Some advanced harvest heads also have debarking capabilities, removing the bark from the stem in the process. Diameter and length measurement. Harvest heads often incorporate diameter and length measuring systems. These systems use sensors and measuring arms to determine the size and length of the tree stem. This information is crucial for optimizing bucking operations and ensuring accurate log lengths for transportation and further processing. Control and automation. Modern harvest heads feature advanced control and automation systems to streamline operations and improve productivity. These systems may include automatic measuring and scanning capabilities that assess the tree's diameter and length, allowing the harvest head to make optimized cutting decisions automatically. Automation reduces operator workload and minimizes human error, leading to greater efficiency and precision. Safety features. Safety is a paramount concern in the design of harvest heads. They incorporate various safety features to protect both the operator and the machine. These features may include proximity sensors that detect objects in the vicinity, emergency stop mechanisms, and safety interlocks that prevent unintended operation. Maintenance and serviceability. Harvest heads are designed for ease of maintenance and serviceability. They feature accessible maintenance points, allowing for routine inspections, lubrication, and replacement of wear parts. Additionally, some harvest heads are equipped with diagnostic systems that monitor their performance and provide maintenance recommendations, ensuring optimal operation and reducing downtime. Compatibility and adaptability. Harvest heads are available in various configurations and sizes to suit different forestry machine models and applications. They can be easily attached or detached from the machine's boom or arm, enabling versatility and adaptability for different harvesting needs. Some harvest heads offer quick coupling systems for efficient attachment changes, increasing operational efficiency. Towing and gathering timber from forests to yards and transporting it to pre-processing factories near industrial timber forests is a complex and crucial process within the timber supply chain. It involves a series of interconnected activities that require careful planning, efficient equipment, and effective logistics to ensure the smooth and timely movement of harvested timber. The first step in this process is the collection of harvested timber. Skidders, forwarders, or other specialized machines are deployed to efficiently gather the timber from the forest. These machines have the capability to load and transport logs or bundles of logs, making them suitable for navigating the rugged terrain and challenging conditions often encountered in forestry operations. Once the timber is collected, it is brought to designated yards or log staging areas near the industrial timber forests. These yards serve as temporary storage locations, strategically positioned to optimize transportation logistics. Factors such as proximity to road networks, pre-processing factories, and the harvesting sites themselves are considered in determining the location and layout of these yards. Upon arrival at the yards, the gathered timber undergoes a sorting and preparation process. Skilled workers or automated systems assess various characteristics of the logs, including species, length, diameter, and quality. Based on these factors, the timber is sorted and organized into appropriate stacks or bundles. This step is crucial for subsequent transportation and pre-processing stages, as it ensures that the timber is properly classified and ready for further handling. Loading the timber onto transport vehicles is a critical aspect of the towing and transportation process. Cranes, loaders, or hydraulic grapples are used to lift and load the logs onto trucks or trailers. It is essential to ensure that the loaded timber is securely fastened or covered to prevent shifting or damage during transit. Safety considerations are paramount, both for the operators involved in the loading process and for the integrity of the transported timber. Efficient transportation logistics play a key role in the successful movement of timber from the yards to the pre-processing factories. This involves meticulous planning of optimal routes, considering factors such as road conditions, weight restrictions, and distance. Transport vehicles such as trucks or trailers equipped with appropriate loading and unloading mechanisms are used to transport the timber. Coordinating with transportation providers and adhering to regulations regarding permits, documentation, and safety standards are crucial to ensure a smooth and compliant operation. The pre-processing factories, located near the industrial timber forests, receive the transported timber for further processing. The proximity between the factories and the yards reduces transportation time and costs, facilitating seamless integration into the production chain. At the pre-processing stage, the timber may undergo activities such as debarking, sawing, and grading, preparing it for subsequent manufacturing or distribution processes. Throughout the entire towing and transportation process, environmental considerations play a significant role. Sustainable forestry practices, including responsible harvesting techniques, minimization of soil disturbance, and mitigation of potential impacts on wildlife and ecosystems, are essential. Compliance with relevant environmental regulations and the implementation of eco-friendly transportation practices contribute to the overall goal of sustainable forest management. Once the logs are cut into standard-sized billets, they are carefully transported from the cutting site to the sawmill. Depending on the distance and logistics involved, various methods of transportation may be employed, including trucks, trailers, or specialized logging equipment. It is crucial to ensure secure loading and proper fastening to prevent any damage or displacement during transportation. Loading logs onto pallets. At the sawmill, the logs are unloaded from the transportation vehicles and prepared for processing. One common method is to load the logs onto pallets. Pallets provide stability and facilitate efficient handling of the logs within the sawmill. Care is taken during the loading process to arrange the logs in a way that maximizes the use of space and ensures safe and organized movement within the facility. Machine peeling. Once the logs are loaded onto pallets, the next stage is machine peeling. Machine peeling involves removing the thin outer layer of the log, known as the bark, without affecting the quality of the wood inside. This process serves multiple purposes, including enhancing the aesthetic appearance of the wood and preparing the surface for subsequent processing stages. Specialized machines called peelers or debarkers are used for this purpose. These machines employ rotating spindles or knives that carefully strip away the bark from the log's surface. The speed, pressure, and depth of the peeling process are controlled to ensure the removal of the bark while preserving the integrity and quality of the wood underneath. Machine peeling provides several advantages. Firstly, it exposes the fresh, clean surface of the log, which improves the visual appeal and quality of the wood. Additionally, removing the bark eliminates potential sources of contamination and minimizes the risk of insects or fungi infestation, enhancing the longevity and usability of the wood. During the machine peeling stage, operators must carefully monitor the process to ensure uniformity and consistency across the logs. Any irregularities or deviations in the peeling process can affect the appearance and quality of the final wood products. Proper adjustment of the machine settings, regular maintenance, and quality control measures are essential to maintain high standards throughout the machine peeling operation. It is worth noting that in some cases, depending on the intended use of the wood, the bark may be intentionally left on certain portions of the log for specific applications or aesthetic purposes. This is typically done through selective peeling or partial debarking, where only specific areas of the log are peeled while leaving the bark intact in other areas. After the pre-sorting of round logs, the next crucial step in the processing of raw wood is cutting it into standard-sized billets. This process requires the use of specialized sawing machines that are specifically designed to efficiently and accurately cut the logs into desired dimensions. The goal of the wood cutting stage is to maximize the usable wood while minimizing waste and ensuring the production of high-quality products with minimal defects and cracks. Achieving this goal requires careful consideration of various factors and employing effective techniques throughout the cutting process. One key aspect of maximizing usable wood is optimizing the yield from each log. Skilled operators assess the log's characteristics, such as its shape, size, and any knots or irregularities present. Based on this evaluation, they strategically determine the most efficient and precise cutting approach to extract the maximum amount of usable wood from the log. This involves making precise cuts that minimize wastage and maximize the volume of high-quality lumber obtained. To minimize waste, operators aim to minimize the amount of wood lost during the cutting process. This can be achieved by carefully planning the cuts to reduce offcuts and by utilizing advanced sawing techniques. For example, optimizing the sawing pattern, such as using live edge or slabbing techniques, can help reduce waste and increase the yield of usable wood. Additionally, efficient log positioning and rotation during cutting can minimize the amount of valuable wood that goes unused. Producing high-quality products with minimal defects and cracks is also a crucial objective during the wood cutting stage. Operators take into account the wood's grain, density, and moisture content, as well as any potential defects or irregularities present in the logs. By carefully aligning the log's grain with the sawing direction and making precise, clean cuts, they minimize the likelihood of defects and cracks in the resulting lumber. Utilizing appropriate sawing machines and maintaining them in optimal condition is essential for achieving high-quality cuts. This includes ensuring that the saw blades are sharp, properly tensioned, and aligned. Regular maintenance and inspection of the machines are conducted to identify any issues that could affect the quality of the cuts. By employing well-maintained equipment and following best practices, operators can consistently produce high-quality lumber with minimal defects. In addition to skilled operators and well-maintained equipment, the wood-cutting stage benefits from quality control measures. This involves inspecting the cuts and the resulting lumber for any defects, such as irregular shapes, excessive cracking, or improper dimensions. Any defective pieces can be identified, segregated, and either discarded or used for lower-grade products, minimizing the impact on the overall production quality. To achieve precise and efficient cuts, experience and skill are crucial. Operators must possess a deep understanding of wood's grain and structure, as well as the characteristics of the logs being processed. By carefully assessing factors such as knots, irregularities, and potential defects, the operator can determine the most suitable cutting approach to maximize the yield of usable wood from each log. Creating billets of standard sizes is a primary objective during the cutting process. Standardization simplifies subsequent stages of processing and manufacturing, as it allows for easier handling and efficient utilization of the wood. These standardized billets also contribute to streamlining transportation to the workshop or processing plant. When the billets are uniform in size, they can be stacked and loaded more efficiently, reducing costs and ensuring the safe and secure transportation of the wood. The choice of sawing machine depends on the specific requirements of the operation. Circular saws, band saws, and chainsaws are commonly used for wood cutting, each with its advantages and characteristics. Circular saws feature a rotating circular blade with sharp teeth, providing fast and efficient cutting. Band saws employ a continuous band of serrated blades, allowing for more precise and intricate cuts. Chainsaws, typically handheld devices, are equipped with chains featuring cutting teeth along the chain's length, offering mobility and versatility. The selection of the appropriate sawing machine is determined by factors such as the size and type of wood being processed, the desired cutting precision, and the production volume. Adjusting the settings of the sawing machine, such as the blade speed and cutting depth, is essential to ensure optimal performance and the production of high-quality cuts. Safety considerations are paramount during the wood cutting stage. Operators must strictly adhere to proper safety protocols, including wearing protective equipment such as goggles, gloves, and ear protection. They should also be vigilant about potential hazards, such as kickbacks or flying wood debris, and take precautions to prevent accidents and injuries. Following safety guidelines and maintaining a clean and organized work environment contribute to a secure and efficient wood cutting operation. Once the raw wood has been processed and cut into billets, the next stage involves selecting and preparing the billets to create boards that meet specific size requirements. This process is crucial in ensuring that the final boards are of high quality and suitable for their intended purposes. Let's delve into this stage in more detail. Board selection. The first step is to carefully select the billets that are suitable for creating boards. Skilled operators examine the billets, considering factors such as grain patterns, defects, and overall quality. By evaluating the characteristics of each billet, they can determine which ones are best suited for creating boards of the desired size and quality. Sizing and trimming. Once the appropriate billets have been selected, the next step is to determine the final size of the boards. Based on the specific requirements of the project or product, the operator uses measuring tools to accurately mark the desired dimensions on the billets. This ensures that the boards are cut to the precise length, width, and thickness needed. Using sawing machines, such as table saws or panel saws, the operator carefully cuts the billets to remove any excess wood and create the boards. This trimming process is crucial for optimizing the utilization of the billets and minimizing waste. Skilled operators consider factors such as grain orientation, defect locations, and the desired appearance of the final boards when making these cuts. Sorting by size and purpose. After the boards have been cut to the desired dimensions, they are sorted based on their size and intended purpose. Boards that meet specific length and width requirements are grouped together for further processing or distribution. This sorting allows for easier handling and efficient organization of the boards, making them readily available for subsequent stages of production. Depending on the size and intended use, the boards can be cut into various sizes and thicknesses. For example, boards used for furniture construction may require different dimensions compared to those used in flooring or cabinetry. Skilled operators employ their knowledge and experience to determine the appropriate cutting specifications for each board, ensuring they meet the required standards. Quality control. Throughout the board selection and cutting process, quality control measures are essential. Operators carefully inspect the boards for any defects, such as knots, cracks, or warping, that may affect their structural integrity or aesthetic appeal. Defective boards are set aside or discarded, ensuring that only high-quality boards move forward in the production process. During the cutting and woodworking stages, excess wood chips or small debris are created. These wood chips, although considered scrap from the cutting process, still have many other important uses. To optimize use and minimize waste, these wood chips are often sent to a mill for further processing. Crushers apply force and friction to break up wood chips, reducing their size and turning them into a more uniform and consistent material. This process allows for easier handling and allows the wood chips to be used in many applications. After the sawing process is completed and the wooden boards have been cut to the desired dimensions, the next step is to arrange the boards in a specific manner to facilitate the drying process. This critical stage ensures that the boards undergo proper drying and conditioning before further use or processing. Let's explore this process in more detail. Sorting and selection. Once the sawing process is finished, the wooden boards are carefully sorted and selected based on their quality and characteristics. Skilled operators visually inspect the boards, checking for any defects, irregularities, or damage that may affect their drying or subsequent use. Boards that meet the required quality standards are selected for further processing. Board stacking. The selected boards are then arranged in stacks or bundles, ensuring that there is a gap between each board. This spacing allows for proper airflow around the boards during the drying process. Stacking the boards in this manner promotes uniform drying and helps prevent the formation of mold or fungi that can result from inadequate air circulation. Sticker placement. To create the necessary gaps between the boards, wooden sticks or spacers, commonly known as stickers, are placed between each layer of boards. These stickers are typically made from kiln-dried or seasoned wood and are of uniform thickness. The stickers help maintain consistent spacing between the boards and allow air to circulate around each individual piece, facilitating proper drying. Stack alignment. When stacking the boards, care is taken to ensure that they are aligned properly. The ends of the boards are typically staggered to create a stable and balanced stack. This alignment helps distribute the weight evenly and prevents warping or bending of the boards during the drying process. Drying environment. The stacked boards are placed in a controlled environment specifically designed for drying. Factors such as temperature, humidity, and air circulation are carefully monitored and regulated to achieve optimal drying conditions. Proper drying environments can include specialized drying chambers, kilns, or covered areas that provide protection from external elements and facilitate efficient drying. Drying duration. The length of the drying process depends on various factors, including the type of wood, board thickness, and desired moisture content. Drying times can range from several weeks to several months. During this period, operators regularly monitor the moisture levels in the boards using moisture meters or other measuring devices. This allows them to track the progress of the drying process and ensure that the boards reach the desired moisture content for their intended use. Quality control. Throughout the drying process, quality control measures are implemented to identify any issues or defects that may arise. Operators inspect the boards for signs of improper drying, such as warping, splitting, or discoloration. Any boards that do not meet the quality standards are removed or segregated for further assessment or corrective actions. Properly drying the boards ensures their stability, reduces the risk of damage or defects, and prepares them for subsequent processing or manufacturing stages. It is a critical step in ensuring the longevity and quality of the final wood products. Look at it. It's like the trunk of this tree has been damaged by termites, and can only be discarded or turned into firewood. But the great thing is inside. Let's test it together. First, we cut off the bad wood at both ends of the trunk. Caution must be exercised as large trees like these are rare, and cutting too much can cause great damage. The subsequent task is to address decayed trees by aligning the appropriate angle to eliminate as much damaged wood along the trunk while preserving its quality and size. It is essential to strike a delicate balance, ensuring the maximum removal of decayed wood without compromising the overall integrity and dimensions of the trunk. Careful precision is required to successfully treat the affected areas and maintain the structural strength of the tree. Surprisingly, the broken part was removed, revealing a wooden trunk with a diameter of 193 centimeters. Continuing the process, proceed with making slabbing cuts along the marked lines, systematically moving from one cut to another until the entire trunk is sliced. Maintain a straight and uniform cut, adapting your approach to account for any irregularities in the trunk's shape. Upon completion of the slicing, conduct a thorough examination of each slice for potential imperfections like knots or cracks. Based on your intended purpose, decide whether to eliminate or reinforce these areas. To achieve the desired finish, use a sander or planer to smoothen the surfaces of the slices. Pay attention to detail to ensure the final product meets your requirements.